Hello students, welcome to TIME. I hope by now you are thorough with the basics. It's now time to begin the exercise. Let's begin with test your basics. Look at the first question. The product of additive inverse and the multiplicative inverse of 3 is dash. Now, what is the additive inverse of 3? You have to take the same number and take the opposite side, right? 3 is what? Positive inverse. Let me first write it. Additive inverse of 3, right? Additive inverse of 3 is equal to, you take the same 3. Since we are talking about plus 3, we have to take the opposite side. That's all. Next, what is the multiplicative inverse of 3? Multiplicative inverse of 3. What should we do? We should take reciprocal. Here no sign change. You have to just take the reciprocal of the given number. Now what are we supposed to find out? The product of the two. What is meant by product? Multiplication. Product of what and what? Minus 3 and 1 by 3. 3 and 3 get cancelled. Minus 1 is the answer. So, the product of additive inverse and multiplicative inverse of 3 is minus 1. Now, look at the second question. The sum of multiplicative inverse of 1 by 12. What is the multiplicative inverse of 1 by 12? Just now I told you. You have to take the reciprocal of the given number. Right? Multiplicative inverse of 1 by 12. What is the reciprocal of 1 by 12? Simply 12. What is the additive inverse? The additive inverse of what? 6. Additive inverse of 6. What should we do? It is plus 6. So, additive inverse will be minus 6. Okay. So, we have to find the sum of these two. Sum of what and what? 12 and minus 6. Now, what is this? You are adding, like you can write it like this, right? 12 plus of minus is minus 6 is equal to 6. Therefore, 6 is the answer. Now, let's look at the next question. Look at the next question. The HCF of 77 and 55 is, see there are two different methods. How you can use prime factorization method or division method, or sometimes you can decide just by looking at the numbers. For example, 77. The moment you look at it, you know it is in 11 table. You are in 7th class, you should know it, right? So, what is 77? 7 into 11. What is 55? 5 into 11, right? Okay. Now, if you carefully observe, 7 and 5 are co-prime numbers. 11 is common. Therefore, HCF is equal to 11, right? Otherwise, what you can do? You can go ahead and proceed in division method or prime factorization method. Let us do that also. We will get the same answer. So, now what will you do? You will be dividing 77, 55 by 11. Both are present in 11 table. Now, 7 and 5 are co-prime numbers. They don't have any other common factor other than 1. Their HCF is 1. Therefore, what is the highest common factor of 77 and 55? It is simply 11. Okay. Next. Now, coming to LCM. Actually, 96 is a multiple of 24. So, straight away you can say the LCM is 96. Or you can proceed like using division method or prime factorization method. So, 24 and 96 both are even number. Divide by 12. I mean 2. 12 2s are 48 2s are. Again 2. 6 2s are 24 2s are. Again 2. 3 2s are 12 2s are. Now, 3 is not divisible by 2. 12 is divisible by 2, but both are divisible by 3. So, 1 4, right? So, again 2 we can do. 1 2, and finally, if you divide by 2, you will get 1 comma 1. Right. So, what is the LCM? Multiply all these numbers here. So, what is the LCM of this? You have to take how many 2's are there? 1, 2, 3, 4, 5. Okay. So, simply you can write 2 power 5 or you can write 2 5 times. Then what? 3 is here. Alright. So what is 2 power 5? 32 into 3. What is 32 into 3? 96. We already know that 96 is the LCM because 96 is a multiple of 24. Okay. So the LCM is 96. Here the HCF is 11. Now let's look at the next question. Look at the next question. 1 minus 2 plus 3 minus 4 plus 5 minus 6 etc. up to minus 1000. We have to find the value of this sum here. How do we go about it? If you carefully observe, let me take the numbers first. 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus etc. What is the last one? Minus 1000. So what should have been the one before that? 999, right? Plus. So what I am basically doing is I am combining the first two, second set, third set up to the last one, right? Why am I doing that? Because we will get the same value with every pair. See, what is 1 minus 2? Minus 1 plus. What is 3 minus 4? Minus 1 plus. What is 5 minus 6? Minus 1 plus etc. What is 999 minus 1000? Minus 1. Right. Now, there could be like some of you may have tried like this 1 plus 3 and then plus 5 plus etc. up to 999, like some of all the odd numbers, and then minus 2, minus 4, minus 6 etc. Any procedure you go by, you will get the same answer, but we should see which is the quickest possible way. Okay. So, this is better. Okay. Here, the next question is how many pairs are there? Because I don't know how many. This is repeated addition. Repeated addition is multiplication. For that, you should know how many times minus 1 is being added to itself. Right. So, totally from 1 to 1000, 1000 numbers are there. Now, if you pair them up like this, 1 minus 2, 3 minus 4, etc. In a pair, there are two numbers, right? So, 1000 will give you 500 pairs. So, from each pair, we are getting 1 minus 1, right? So, how many minus 1 will be there? 500 will be there. So, this is nothing but minus 1 into 500. What is minus 1 into 500? Minus 500. Is it present among the choices? Yes. Choice 2 is the correct answer. Look at the next question. The value of 54 into 73 plus 27 into 54 is dash. You don't have to multiply these two, multiply those two and then add. It is lot, you'll get the correct answer, but it will consume a lot of time. So, this is when you should use the properties you have learned. You have learned properties of integers under multiplication, under addition, right? This is the time you have to use them, right? So, now if you carefully observe, both of them like this pair and that pair have 54 in common. Okay. So, what I am going to do, let me first write down what is there. 54 into 73 plus 27 into 54. Right. So, the thing is 54 is the first number here, 54 is the second number there. You can change the order using one property. What is it? Commutative property. Using commutative property, this will come here and this will go there. 54 into 27. What is the property we are using here? Commutative property. Under multiplication, right? Commutative property. What is commutative property? It says A into B is the same as B into A. Right? Okay. Now, if you carefully observe, this is of the form A into B plus A into C. Right? So, can I pull, what property is that? Let me take more space, okay? Let me just write it here. Now, if I pull 54 outside, okay, what do you have inside? 54 into 73 plus, because we have plus here, and then 54 multiplied with 27, right? 54 into 73 plus 54 into 27. What property is that? Distributive property. Yes. So, we are using distributive property here. Distributive property. What does the property say? It says that A into B plus C is equal to A into B plus A into C. That's what we are using here, right? So, it is actually right hand side is given A into B plus A into C. We are using the left hand side to shortcut A into B plus C. Why? Because instead of multiplying individually and then adding, if you pull out the common factor, if you add this and multiply, work will be over. And most of the time, interestingly, these things will add up to some multiples of tens or powers of tens. Here, what are we getting here? 54 into, what is 73 plus 27? 100. What is 54 into 100? 5400. See, 5000 multiplying this way, is easier than individual multiplication and then adding. That's why you should be thorough with the properties. Is 5400 present among the choices? Yes, it is the first choice. Now let's look at the next question. Look at the next question. If the product of two integers is minus 56, then which of the following pairs of integers satisfy the condition? Now, you have been given 4 pairs of integers under A, B, C, D. Product means what? Multiplication. Let us see where we get minus 56. Let me take first A. First of all, we know that it is a negative answer, right? Minus 56. In order to get a negative number in a product with two numbers, two integers, one should be positive, one should be negative. The moment you look at the choices, this is definitely not valid because it is having both negative. Take a look. Here both are negative. So, definitely B cannot be the correct choice. One should be positive, one should be negative, which is satisfied in A, C, D. And also you can quickly do the multiplication. 7 8s are 56, 14 4s are 56, 2 28s are 56. Or if you want to be sure, you can go ahead and try each and every choice. What is minus 7 into 8? Minus 7 into 8 is minus 56. Similarly, this will not work out because B minus 7 into minus 8 is equal to minus into minus plus 56. That's not what we want. We want minus 56. And then what? 14 into minus 4. Plus into minus is minus. 14 into 4 is 56. And finally, D minus 2 into 28. Minus into plus is minus. 2 into 28 is 56. Only choices A, C, D satisfy the condition. Look at the next question. If the LCM of two numbers is 36, then which of the following cannot be their HCF? I would like to give you some examples to let you know some important note. Okay. Let me take 4 and 8. Okay. What is the LCM of 4 and 8? 8. What is the HCF of 4 and 8? 4. Now, if you carefully observe, 8 is divisible by 4. In other words, 4 is a factor of 8. Let us take one more example. LCM of 12 and 15. What is the LCM of 12 and 15? 4 3s are 12, 5 3s are 15. 3 is common, right? So, 60 is the LCM. What is the HCF of the same two numbers 12 and 15? 3. Okay. Now, again 60 is divisible by 3 or 3 is a factor of 60. So, remember HCF is a factor of LCM. Okay. Now, how to solve this problem? We have to look at every choice given and see whether it is a factor of the LCM. What is the LCM? 36. Is 3 a factor of 36? Yes. 3 12s are 36. So, 3 can be the HCF. Now, go to 4. Is 4 a factor of 36? Yes. 4 9s are 36. Now, coming to 6. Is 6 a factor of 36? Yes. 6 are 36. What about 7? 7 is not a factor of 36, right? Therefore, 7 cannot be the HCF of the two numbers whose LCM is 36. I hope this is clear. Now, let's look at the next problem. Look at the next question. If the HCF of two numbers is 12, then which of the following cannot be their LCM? It's like reverse of the previous question, right? So, what is happening here? HCF is given. They are asking us to choose which one of them cannot be LCM. So, the same examples, whatever we took earlier, can help us understand this also, right? So, let us take 12 and 15, okay? What is the LCM of 12 and 15? LCM of 12 and 15 is 60. What is the HCF of 12 and 15? HCF of 12 and 15 is 3, right? Now, what is the connection? Just now we learned that HCF is a factor of LCM. Now, what about LCM? LCM is always a multiple of HCF. See, 60 is a multiple of 3. What is 60? 60 is 23s are 3 into 20. It's a multiple of 3, right? So, LCM is always a multiple of HCF. So, now we have to go ahead and look at every choice present here and check which one is not a multiple of the HCF. What is the HCF given to be? 12. Is 36 a multiple of 12? Yes. What is 36? 12 3s are 36. Next is next one, 24. Is 24 a multiple of 12? Yes. 12 2s are 24. What about 45? No. Actually, you cannot express that as a multiple of 12 at all, right? So, this is the correct answer. Just to finish the problem, look at 60. 60 is nothing but 12 5s are. This is also a multiple of 12, the HCF, okay? So, first, second and fourth choices are multiples of the HCF 12, but the third choice 45 is not. Therefore, 45 cannot be the LCM of the two numbers. I hope these were clear. Now, let's look at the next problem. Look at the next question. We have to match column A, items under column A with items under column B, right? The moment you look at the table, it is crystal clear that they are nothing but properties of integers under addition and multiplication, right? Okay, look at the first one. A into B plus C is AB plus AC. What is it? Distributive property, right? We are distributing this A to every term inside the bracket, A into B plus A into C, right? So, where is that? Is it present among these? Yes, T is the correct answer. Next, A into B is equal to B into A. Whichever order you take and multiply, answer is going to be same. For example, 3 into 4 is equal to 12. 4 into 3 is also 12. What property is that? Commutative property under multiplication. Where is it? Here it is. It is, yes. If you are thorough with the properties, you can answer this yourself. There is nothing to do. You should recognize and just write the correct answer here. That's all. A plus B plus C is equal to A plus B plus C. You have three integers, right? For example, 1, 2 and 3. You first add these two, 2 plus 3. What is 2 plus 3? 5. 5 plus 1, 6. Or you add these two first. 1 plus 2, 3. 3 plus 3, 6. Either way, whether you add 2 and 3 first and then add to 1, or you add 1 and 2 first and then add to 3, whatever you do, answer is 6. What property is this? Associative property under addition. Is it present among the choices? Yes. R is the correct answer. They are already in the correct order, matching. Now, 1. The moment you look at it, what do you understand? 1. Multiplicative identity. For P, if P is any integer, P into 1 is P. 3 into 1 is 3. 0 into 1 is 0. Minus 3 into 1 is minus 3. Right. So, it is called as what? Multiplicative identity, or this refers to multiplicative identity property. Now, 0, same. You add 0 to any integer, you get back the same integer. 7 plus 0 is 7. Minus 4 plus 0 is minus 4, right? So it is called as additive identity property. If you are thorough with the properties, this doesn't need any help, you can do it yourself. So I hope everything was clear. I hope by now you are thorough with the basics. I also hope you tried the problems and test your basics. It's now time to move to the next level of questions called UBQ, understanding based questions. Look at the first question under understanding based questions. Find the greatest number which divides 84 and 77 and leaves a remainder 3 and 5 respectively. So here, now let me give you an example. We know 4 is not divisible by 3. You cannot divide 4 by 3. Of course, you can divide, but you will get decimal answer. The remainder will not be equal to 0, right? So, what happens when you divide 4 by 3? 1 3s are 3. What is the remainder? 1, right? 1 is the remainder. Now, if I remove this 1 from 4, like 4 minus 1, what happens? I get 3. And 3 is exactly divisible by 3. Yes or no? 3 ones are 3. When you divide by 3 by 3, you will get remainder as 0. Let us take another example. Say you have 16. 16 is not divisible by 5. When you divide 16 by 5, what do you get? 3 5s are 15. Remainder is 1. If you remove this remainder 1 from 16, you get what? 15. 15 is exactly divisible by 5. 3 5s are 15. Remainder, no remainder, 0 remainder, right? So, what happens if you remove the remainder from the number? It becomes exactly divisible by that number, divisor, right? So, now carefully read the question one more time. There is some big number, greatest number, okay? When you divide this 84 and 77 by that number, we are getting the remainder 3 and 5 respectively. That is what, let that find the greatest number, right? Let it be x, okay? I am just giving an example. When you divide 84 by x, 3 is the remainder. When you divide 77 by x, 5 is the remainder. Now, if you remove the remainder from this 84 and 77, the numbers, the two, whatever result you get will be exactly divisible by x. Just now I showed you examples, right? So, let us first do that. What are the numbers given? 84, 77. What are the reminders? For 84, 3 respectively, right? You should go in the same order. For 84, take 3. This is not how you write 3, right? You have to write like this. And then, what about the 77? The remainder is 5. After removing the remainder from the numbers, what do you get? You get 81 and 72. Fine. Okay. Next what? What is that number? With which number you should divide? Find the greatest number which divides 84 and 77 to do this, like leave remainder 3 and 5. Now you have to find, like I told you, after you remove the remainder from the numbers become exactly divisible by that greatest number. Now, since it is greatest number, we have to find the highest common factor of these two. Okay. So, we have to find what? HCF of 81, 72. What is the HCF? Let us find the HCF here. 81, 72. 81 is not divisible by 2, but 72 is divisible by 2, but both are divisible by 3. We will go ahead and divide by 3. 27 3s are, 24 3s are, again by 3. 9 3s are, 8 3s are, right? So, nothing else is common now. 9 and 8 are co-prime numbers. We cannot divide both of them by any common factor. So, stops, right? So, what is the HCF then? You have to multiply these two. What is the HCF? 3 into 3. What is 3 into 3? 9. So, the greatest number is 9. When you divide 84 by 9, 77 by 9, you get the reminders 3 and 5. 9 is such a greatest such number. You can't find anything beyond 9 which will satisfy this condition. Okay. If you want, you can cross check. See, now go ahead and divide 84 by 9. What will you get? 9 9s are 81. What is the remainder? 3. Satisfied. Next, go ahead and divide 77 by 9. 8 9s are 72. What is the remainder? 5. Where is 5? Here it is. Right? So, the answer is 9. I hope this problem was clear. Now, let's look at the next problem. Look at the next question. Find the greatest number which divides 144, 249 and 109, leaving the remainder 4 in each case. So, when you divide those three numbers 144, 249 and 109 by that greatest number, every time you get 4 as the remainder. Okay. So, what happens when you remove the remainder from the three numbers? It becomes completely divisible by that greatest number. Right. For example, if you have 23, 23 is not divisible by 5. But if you, okay, let us divide by 5. 4 5s are 20. What is the remainder? 3. If you remove this 3 from 23, what will you get? 23 minus 3 is equal to 20. And 20 is exactly divisible by 5. Right? You get remainder 0 when you divide 20 by 5. 4 5s are 20. So, what are we going to do? First, let us remove the remainder from each one of those numbers. 144 minus 4. 249 minus 4. 109 minus 4. After removing the remainder, what happens? The numbers are exactly divisible by the greatest number which we have to find. Right? So, what do you get here? 105. Now, how do we find that greatest number? Very easy. We have to find the HCF, highest common factor of these three, because the same number is dividing all three, right? It should be common to all three. So, and since they are saying greatest number, we have to find the highest common factor. Okay. So, now what are we going to do? We are going to find the HCF of 140, 245 and 105. Alright. Fine. How are we going to find out? Whatever method you like, you can follow. I am going to use division method. Okay. Now, all the three numbers here, this 140 and then 245 and then 105, right? All of them are divisible by 5. They are ending with 5 or 0. So, they are divisible by 5. So, when you divide by 5, what happens? 28 5s are 140. Here what happens? 49 5s are 245. Here 21. Now, all these are familiar numbers, no? All of them are present in which table? 7 table. When you divide by 7, 4 7s are 28, 7 7s are 49, 3 7s are 21. If you look at 4 7 3, all are like, well, they have only one common factor, which is 1. They cannot be divided by any other number. So, it stops there. Okay. So, what is the HCF? HCF is 5 into 7. You have to multiply those two numbers. So, what is this equal to? 5 into 7 equal to what? 35. So, 35 is the greatest number which divides 144, 249 and 109, leaving the remainder of 4 in each case. Okay. So, what is the answer? Answer is 35. You can also check it. How to check it? Go ahead and divide. You can do a quick cross check, right? So, 144 when you